So thank you very much, Sam. So hi, I'm here to talk about 4D printing and time-dependent 3D printing. I'm going to explain way more about these two words and these two phrases throughout this presentation. But firstly, I just want to give an overview of who I am. So I'm recently Dr. Ellis Marshall. I've just finished my PhD in 3D and 4D printing at the University of Hull. I've been in industry quite a bit, and I'm members of a few chemical societies as well that I put on there as well. Me currently, I work at the Innovation Centre, which is part of the University of Hull. And what this place is a low carbon innovation centre aimed to help us transition into a low carbon economy. This is based near Hull, so East Rhine of Yorkshire, North East, all the way up in the middle of England, basically. Yeah, so my role there is the technical manager of this workshop, of this place, and it's a fab job and it's a fab place to be. So I just want to say a quick thank you to 3D Crowd. So my role with 3D Crowd was, I was in the Yorkshire region, obviously. I was the coordinator at Hull. So in the Innovation Centre, we were a Hull-based cleaning and distribution hub. And I just want to say thanks to all our volunteers as well that printed all these face guards for us and help distribute them to any orders locally within Hull and York itself as well. So big thank you to all our volunteers that helped. We did 365 at least headbands in our region. We probably did more, but yeah, so a big thank you to everyone who helped, and a big thank you to everyone at 3D Crowd. You guys are awesome. So I just want to give everyone a flat base of what is 3D printing, so we're all on the same level, so we all know what it is. And then we'll move on to the more 4D printing aspects. So 3D printing, very simple, create a 3D object layer by layer, starting from the bottom and another layer on top, and then you keep going in successive layers until you get your object. So this works in the X-axis, the Y-axis, and the Z-axis. And it's a nice, easy process, and it's created all these wonderful headbands that the 3D Crowd have used. Who uses 3D printing as well? All these guys. So we've got NASA, they use 3D printing. Hasbro, so Sweets, Hershey's, they use 3D printing. Apple, Ford, car manufacturers. Architects use 3D printing. Surgeons use 3D printing. And you guys at home use 3D printing. Which is just amazing. So everyone has a 3D printer nowadays, the big boys and you at home in your lounges playing with 3D printers. It's great. So 3D printing in general is 7 different technologies. They can all be used in different ways in different manufacturing industries. We're not going to go into this, but I just want to say there's 7, and they're all equally awesome and all equally have their advantages but also disadvantages as well. But I'm sure that'll be another talk for later on. So now we get on to the interesting topic, 4D printing. So 4D printing uses the 4th dimension. If you've watched a lot of Doctor Who, or you're a sci-fi nerd, or you just love physics and science, the 4th dimension is time. But how does time apply to 3D printing? That's always an interesting topic. I like to think of 4D printing as time-dependent 3D printing. So that probably doesn't help your head get around this anymore. So time-dependent 3D printing. 3D printing, so say 3D print a flat sheet, but it will continue with effects that continue beyond that print. Not with me yet? I'll keep going. So, time-dependent 3D printing. So, on the left, say it's midday, you've 3D printed a flat sheet of paper. You put it in a bath of water at 12:01. At 12:02, you take it out of the bath of water and it's changed shape. It's changed over time to another shape. So that is time-dependent 3D printing. So again, you can 3D print an object and it just sits there. But time-dependent 3D printing is you react it, or you give it a stimulus and it changes shape or function even. So some examples. So time-dependent 3D printing can not only react with water, it can react with heat, light, current, so electrics, magnetism, and it can also be a chemical reaction. or a reaction to a chemical stimulus, so like acid or alkali. So on the right here, we've actually got some examples of time-dependent 3D printing. We've got a snowflake shape. You could quite easily see yourself 3D printing a snowflake shape quite easily. You stick it in a bath of water or you heat it up though, it does nothing. But if you 3D print with this time-dependent technique, it changes shape if you heat it up. So it goes into a flower shape rather than a snowflake shape. Are you still with me? I hope so. And it's also inspired by flowers, this whole technique is sort of very flower influenced. So again, we've got a flower at the top. You start out with a flat flower, and you give it some heat and it will curl up and curl up and curl up. And it will also, when the heat is taken away, it can retract back to its flat shape. How does time-dependent 3D printing occur? Well, you actually use a 3D printer, but you play around with the material inside. You use a different material than your traditional PLA or PETG or ABS. You use a different material. This is where I just want to do a sidestep into my research area. Like I said, my research was 3D and 4D printing, and this will hopefully explain a bit more about the 4D printing side. My research area was to tackle climate change, big topic. So in 2018, CO2 levels were 407, and today they're now 416 ppm. You can look at what tomorrow's are, yesterday's are on co2.earth. I would recommend you go there. But, so, my research area was 3D printing these little nanocrystals with a 3D printer to make 4D printed materials. So, what these 4D printed materials can do is they can react with CO2 or other pollutants and change and take them out of the water. Are you still with me? I hope so. So, time-dependent 3D printing, as a little summary, can react to heat, water, light, current, magnetism, and they can be affected by chemicals. Okay? Applications of 3D printing, though, or time-dependent 3D printing. So, who uses it? Currently, there's only about 4 major players in this 3D printing technology, or 4D printing technology. We've got Autodesk, NASA, so space, Adidas Shoes, and the 2 3D printing companies there. So, how do Adidas use 4D printing? This is their supposedly 4D printed reflective shoe. So what is 4D printed in here is they've 3D printed this midsole or this mesh area, and this mesh area reacts to pressure and it can expand and contract, just like a running shoe would. But the beauty of it is it's been 3D printed and it reacts to an external stimulus, which is your weight going on it. So you can call it 4D printed or time-dependent 3D printed. So another fabric or another material that's 4D printed or time-dependent 3D printed is NASA's space fabric. So they're looking to use this on in space, on ships, but it's a very reactive material, well, reflective material, I would say, and it looks like chainmail, and it works a bit like chainmail as well, and it can mold to a shape and stay in a shape, or it can change shape to a different stimulus. It's incredible material. I would really recommend looking up the NASA space fabric. So another area of 4D printing. So this is actually really cool. These are stents in arteries, and what they do is they react to the heat of the body and expand. So when you put them in the body, they're nice and small, they can fit down the vein quite nicely. When blood starts flowing and starts to heat up, it expands, and you've got a stent in there, which is incredible technology. And I think there's a big future in the medical applications. On these medical applications as well, I just want to say the future is crazy and it looks brilliant for 3D printing or 4D printing of organs or body parts. They've done 4D printed ears, hearts, lungs. So the picture in the middle here is a lung. There's blood going through it and there's oxygen coming in and out. And on the right, I think that's a liver. A model has been 3D printed, and then it doesn't fully function yet, but it's on the way to functioning. This is incredible technology, and this is the future of 3D and 4D printing. You could replace your ear if it's come off. And the beauty of it is you can use your own skin grafts. There's no anti-rejection medication needed because it's your skin going back onto your body. So, a summary. Time-dependent 3D printing is 3D printing with effects that continue beyond the print. And these can react to water, heat, light, current, magnetism, or a chemical stimulus. It can be any one of those. Yeah. So thank you very much. I just want to have a quick little sort of a quick look here. So here is my recycling technique that I'm currently doing at the Your Innovation Centre. So a quick shout out. If you have recycled waste or any old PLA, used PETG parts, failed, whatever, and you want to reuse them or get them recycled rather than chuck them in the bin, I'd welcome them at my centre. And what we do is shred it down and make it into a new roll of filament for me to use for students or other applications. So we're trying to be green and low carbon by saving it going in your waste bin. So yeah, thank you very much. Thank you very much for your time. And if you want to get in touch, I'm on Twitter, I'm on LinkedIn, and I've got my email address here. So thank you to 3D Crowd, thanks to the University of Hull for me, and thanks to Your Innovation Centre. So thank you very much. And any questions?
Great, thanks, Ellis. I'm sure there'll be lots of people who've got failed headbands to send to you. So we've got a question from Andrew of what is your particular speciality?
Yeah, so it's metal organic frameworks. So they're crystalline materials, and I've synthesized them and put them into plastics and 3D printed with them. So these can be used to degrade, well, I've done a paper and it's degrading nerve agents. So these can be placed into a solution and used to degrade pollutants to the atmosphere. Nerve agents are one. They can also be used to take up CO2. So they're carbon capture devices in a sense.
Great. We've had another one from Norv that's asking, how do you see your carbon-eating nanoparticles being used?
So I see them being used. So once they've been 3D printed, once they're in this shape, I see them being used in filters. So such as the large, gas masks filters. So they could be placed into that and taken out and reused, washed and placed back in. They could also be used in power station flue gases. So you could put them in there, take them out, wash them, put them back in. So they're reusable and recyclable, which is a major benefit. I like the 4D printed heart, I would say. That is very cool. But I have just read up on some heat reactive curtains. So they will open and close when it's hot or cold outside, which is a very strange application for 4D printing.
Great. Well, I think that's... Oh, we've got one more question that's just come in from Ian of, could your CO2 cleaning particles be used in the home?
Yep, don't see why not.
I guess, is there any particular applications maybe you've tried already that they might be useful for?
I mean, they could work alongside air fresheners. So a lot of these air fresheners have carbon filters in, which is just a sheet of carbon. And so what you could do is replace that carbon sheet with my filter, which would be reusable and washable. So you could take it out yourself, rinse it, put it back in. So it could be used alongside these air fresheners that have fans in that circulate the air around.